So, let's do this again. Lukas Seiler from LiveKit is asking a very important question. Why can't we all just get along? As I was saying earlier, WebRTC is supposed to be a standard, and Tim will probably have some opinions on that. But reality, interoperability is not so easy. So, thank you very much. Take it away.
Thank you. Hi, everyone, and welcome to my talk, Why Can't We All Just Get Along? WebRTC edition. And I'm going to talk to you today about some of the common pitfalls you may encounter when dealing with WebRTC, both across different browsers and also mobile clients. So first of all, just quickly introduction from me. Hi, I'm Lukas. I work at LiveKit, and I'm primarily concerned with all things that run on client hardware. And LiveKit, for those of you who don't know, it's a set of tools and services with real-time media and especially WebRTC at its core. And I spend most of my time working on the JS client libraries and their extensions, which of course means I'm constantly fighting against cross-browser inconsistencies, and while still trying to bring new advancements to as many users as possible. And I'm here today to tell you about some of the hoops that we have to jump through to make that happen. But instead of only complaining about all those issues, which I'm sure I will also do throughout the talk, I also want to share with you some of the measures we've been taking to address them. So first of all, for the sake of the talk, I'll just broaden the scope of what WebRTC entails a bit. And at LiveKit, the approach to WebRTC is pretty much end-to-end. So trying to abstract away media handling as much as possible to account for inconsistencies there, have some sane defaults, especially around codecs, to try to catch issues there. And the goal with this approach is to solve undifferentiated problems that most people trying to integrate with a WebRTC solution would probably face at some point anyways. So when I talk about WebRTC today, this will include media input, output, encoding, decoding, all these kinds of things. And let's start with browsers. So I've only included the three main ones here, which is Chromium-based, Firefox, and Safari. And just quickly wanted to shout out to WebRTC Adapter, which is taking away a lot of the pain points, especially around the WebRTC API. And if you don't know it, it's awesome. Check it out. It's on GitHub, WebRTC hack/adapter. And it takes takes away a lot of the issues already. Just a quick public service announcement that Safari version parsing has stopped working in WebRTC Adapter. So for some specific Safari versions, it's broken right now. To start off with media input and output, and while capturing and outputting media is not strictly part of WebRTC, the question of it arises as soon as you try to transmit live media data. And of course, one constant source of pain is get user media, and how difficult it is to deal with get user media can be seen that we had a workshop yesterday dedicated to the topic exclusively by Tarush and Palash, and I think that already says a lot. So I'll just quickly recap some of the common pain points that we've seen. Of course, there can be hardware bugs, and most of the time, there's absolutely nothing you can do about it. Then there's some inconsistencies with constraints of different things you might get back differently on different browsers. One example of that is cropping. So if you specify for a video track that you want specific dimensions, Chrome is the only browser who actually allows you to have a resize mode constraint that specifies either I get the exact dimension spec that I want or I get the closest match. And then there's Firefox, who always returns the closest match and never crops. And then there's Safari, and Safari always crops and never does it the Firefox way. So there's actually no way to get them all working the same, which is of course annoying. And then favorite topic of everyone, permissions. Prompting users for permissions is of course great and important, but it does feel weird that APIs like enumerate devices do in fact require permissions to have any meaningful output, but they do not prompt for permissions, and even that non-meaningful output is very inconsistent across browsers in what you get back. And if you have the media stream, the next step is validating that media input and trying to find out am I actually getting anything meaningful from that point onwards? And so there's 3 different things, which are all basically just indicators. None of them work exclusively. And even if you do all of them, there might still be some additional things, but this is the best we can do currently. And if anyone has any other suggestions, please feel free to talk to me afterwards. I'm happy to take those suggestions in. So there's a muted property on a media stream track. And unlike the name says, muted does not actually mean that someone muted the media stream track. In fact, what it means is that that media stream track is temporarily not able to produce any media output. I have not found any more clear definition of what that actually means, but the important part is to know there is events for it, mute and unmute, that you can listen to and handle them, and display something to your user or the developer, whatever whoever you're targeting. Then another option is to inspect the actual output. So for audio, that would mean you could basically hook up the media stream track to WebAudio, run a WebAudio analyzer node on it, do an FFT, check for the samples, and check if they are absolutely silent across the frequency spectrum. And if that's the case, this is not something that normally occurs with microphone devices, then you can be pretty sure something is wrong. But there's also, of course, some caveats with that approach, because there's hardware switches, and hardware switches on microphone might do that. And we've also seen this with newer devices that have background noise reduction, but rather for microphones instead of headphones. So in that case, the software might actually also just silence everything. So it's definitely not a fail-proof solution to only look at that. And for video, it's pretty much the same, but instead of web audio, you pass it to a canvas and you inspect the actual pixels. You don't have to run over all of them, but if you have a couple of pixels that are absolutely black, like my screen now, this is stupid. Thanks. That will probably happen again. Yeah, if you have a couple of pixels that are entirely black, it's a similar indicator that something might be wrong, unless you have a certain kind of hardware switch. I've yet to see a video camera that works that way, but I also don't have that many devices to check on. And the last option, or the last indicator you can use, is to regularly check get stats on the sender. But of course, that has a drawback in terms of you actually have to start sending stuff, and it has a bit of a delay until get stats gets populated. And then we can look specifically at audio output, and there's a bunch of issues just with that. For one, selecting the audio output. This is currently only working in Chrome via an API called setSyncID. Is not supported in Firefox and Safari, but Firefox 115, which is currently in beta or alpha, will ship it. But I just learned yesterday from Chris that even if that has landed in Firefox, that's not the end of the story. So there's a bit of confusion how it will actually work, but it seems like, from what I've read on the spec now and from bug reports last night, it seems like for Firefox you first have to call a new API called select audio output, which will prompt the user to select an audio output device on the browser. That will give you back a media device info. And after that, if you call enumerate devices, that audio output that you've selected will be part of the enumerate devices call, but not before. So even though things are converging in some paths and things seem to get better, there's also some places where it just diverges even more, and things might not end up in a very happy path for the future. And the second part is auto playback of audio tracks, and this has also become increasingly more painful. It does arguably have its good sides, because you don't want to go to a random website and have 100 different audio players playing back. But in the context of a WebRTC application, it's sometimes simply annoying. Specifically, most of the time what happens is that audio playback is being blocked if the playback is not initiated directly through a user gesture. And different apps have been working around this successfully by either starting an audio context on the first click of the page, or you display a start audio button in case the audio playback got blocked, because it will throw an error. And as soon as Charlie joins, auto playback for Alice breaks again because there has been a moment in time where there was no audio playing back, and Safari just resets the playback policy at that point. So we do have a rather hacky workaround for this, which is in the start audio function that you can press on a button. We just start an audio element with silent web audio, and that will just stay there for the duration of the call. And not really happy with the workaround, but it seems to fix the underlying issue, which is annoying, but there's workarounds. One more audio issue, which a customer of us called the happy birthday problem. And I liked it very much. And there's, additionally to the WebRTC version, there's actually a probability problem that is called the happy birthday problem. And that I want to share that with you first. So the problem goes like this. In a random group of 23 people, what's the likelihood of 2 of them sharing the same birthday? And I know we've had 2 people sharing the same birthday here already. We're a bit more than 23 people, but that has happened. Any ideas, any estimates on how likely that might be?
High 90s.
What's that?
High 90s.
High 90s for 23 people to share the same, okay? 50-50.
70.
70. Wow, I wasn't expecting it to be way less. Yeah, 30%. Okay. You got it right. It's 50%. It's pretty much exactly 50% likelihood. And the math does check out. I didn't include it in the slides, but you can Google it. It's the first thing that'll come up if you Google the happy birthday problem. But of course, the WebRTC edition of that problem is a bit different. And the WebRTC version goes like this. In a conference call with 5 people using random browsers, where it is one person's birthday, how likely is it that that person can hear all of the other 4 participants if they were to sing happy birthday for them at the same time? So we do consider the network conditions to be great. So transmission is not the problem. Just to get that out of the equation. Any estimates? 0. 10%. 50. Okay. So it turns out it's very much connected to how likely it is that the user is using a Chromium-based browser. So the probability of the user having a Chromium-based browser is above 70%. I didn't find exact numbers. So the probability of you being able to hear everyone, like 4 people at the same time, without any artifacts is less than 30%. And I brought some audio samples to showcase what that sounds like. First of all, I'm going to play back the version in Firefox, which does not have any artifacts. And the way I did it was just having 4 tracks, and each of them plays back a sine wave on one frequency, and you can hear, like, it doesn't sound great, but it's like this harmony thing. You will hear it right now, hopefully. It's not nice. Sorry. But what you can hear is it doesn't sound nice, but there's no crazy artifacts or anything. And now it's the exact same setup, the same sample app that I came up with, but just playing it back in Chrome. So yeah, I think it's enough. It's annoying to listen to that. And I'm not entirely sure what's happening, but it seems that Chrome, if there's more than 3 remote audio tracks playing at the same time through an audio element, it tries to mix them in a way that it will always select the loudest ones. So if there's the volume is the same for all of the sine waves that I'm playing, so it's constantly trying to change between them. And that causes the artifacts. And of course, in a normal meeting situation like Google Meet or Duo or whatever, you might not run into this because you don't have so much people speaking over each other at the same time. But for the happy birthday use case, where you want to hear everyone singing at the same time, it just doesn't work. And yeah, there's a workaround for this. If you pipe all incoming audio directly through web audio, you don't have that restrictions. It's only if it plays back through HTML audio elements. So I went up in the demo to, I think, 16 tracks, and it was still working with web audio in Chrome. And with that, we jump into encoding and decoding, and we'll start off with codecs. And there's the same browsers as before, a bunch of codecs, and looks great on first sight because there's so many green check marks, but of course there's some caveats with it. One of them is that that some specific codecs only landed rather recently in the browsers, and as you can see, AV1 is not supported for Firefox and Safari, but even if we ignored it, VP9 only landed in 15.0 in Safari, and historically there's been a time where basically Firefox did not support H.264, and Safari did not support VP8, so there was no way to interrupt the two for a video call in WebRTC. Luckily, this has changed. A bit of history. And if we look more closely, then we see stuff like H.264 profile levels, and depending on the browser, different profile levels are supported, and this profile layer also determines whether or not hardware encoding will be used, so it might actually be of greater interest. Then VP9 support, it is supported across all major browsers now, but Firefox SVC is not supported, so scalable video coding is currently not supported. You have to account for that. And then one a bit more deep dive is if you want to do stuff like background blurring and you're capturing a stream from a canvas, so what you would normally do is you take the media stream track, pipe it into a canvas, do your processing with it, background, foreground, apply a blur, and then use a API on the canvas to capture the stream. That works as long as you don't want to use simulcast, because if you use simulcast with that, then it just starts flickering. And we were scratching our heads, why does this happen? And it turns out that if you have different, like for each simulcast layer, you have an encoding specified, and if you have different frame rates for those encodings specified, that will start flickering. But if you give them all the same frame rate, or you don't constrain it to a max frame rate, then the flickering stops. And more specifically, audio encoding and decoding. So there's Opus Red. I don't know how many of you are aware of Opus Red. Just a quick raise of hands. Opus Red. Okay. I'll quickly explain. Opus Red basically means you send redundant data in your RTP packets. So instead of just one slice, you might send two, which greatly improves audio quality in packet loss scenarios. So because you're basically just sending two packets, and the quality in the end becomes a lot better. Unfortunately, of course, only Chrome supports both encoding and decoding of Opus Red. But as I mentioned in the beginning, we still would like to roll this out to as many people as possible because it is a great improvement in audio quality or in perceived audio quality. You can get around this with doing something like, I would call it active read, where the SFU or the server actually does the injecting. So imagine someone is using Firefox and publishing their audio. So they don't have Opus Red support. And then the server basically just injects the redundant data. It buffers a couple of frames or a couple of packets and then injects them. And if the subscriber is Chromium, it will just say, okay, you take this Opus Red stream, and as soon as there's packet loss on the downstream path, it actually improves the scenario. It just doesn't improve the scenario if the Firefox user has problems publishing upstream. And then there's the issue of audio NAC. Audio NAC, NAC just means it's a form of error correction in the sense that if a packet isn't coming through, it can be requested to be sent again, but there's no API at WebRTC to actually enable that. You'll have to do SDP munging client side in order to make it happen, which is annoying. And the same goes for stereo support. It does work on Firefox, but everything else, Chrome and Safari, do not set that required parameter by default. So again, you have to do client-side SDP munging in order to actually only publish stereo, which sounds like a rather basic thing to do. And then a deep dive into what is called RTC, RTP encoding parameters. RTC, RTP encoding parameters is a very nice word and is a dictionary used to describe the configuration of an RTP sender's encoding. So I mentioned simulcast before, and how you specify the different layers is through those encodings. And and those are the parameters for it. This can be very useful in a bunch of scenarios, but of course it wouldn't be their own section if there weren't any problems with this. So there's one parameter called active, and you can see here we have 3 users in a call. User A and user B are both publishing simulcast, 3 layers, and user C is on a slow connection, only publishing 1 track, and each user is receiving each track of the other person. Let's assume this is only video. And what you can actually see, probably not so clear with the colors, but what actually happens is that both user A and user B are publishing 1 layer that is not used by anyone else. So user B selects this layer of user A, but neither user C nor user A are using the middle layer. And the same is happening for user A. So to optimize for this, both bandwidth and performance-wise, you just want to disable that 1 layer dynamically and just start it again if user D joins that is actually using that layer. That's great, and that's a really cool optimization, just doesn't work in Firefox. And there are workarounds for this to basically set the bitrate to 0, but that causes other issues. So this is an optimization, that LiveKit, for example, does out of the box, but we just have to disable it for Firefox because it causes too many problems. So this is the reason why Firefox users on a congested network might have a worse experience currently than they would have to. I think, I have to do some testing next week, but I think the most recent version of Firefox is supposed to address this, and that would be great.
Is that what you refer to as Dynacast?
Yes, that's exactly what we refer to as Dynacast. Second parameter of the RTC, RTP encoding parameters that I want to talk about is priority. And priority basically determines how the user agent or browser engine allocates bandwidth between layers and or senders. That distinction between layers and or senders is important, but I'll talk about that in a second. A common use case for this would be, for example, you want to assign a very high priority to your microphone, and second highest priority is the screen share, because in a screen sharing scenario, you want that to come through. And if there's still upstream bandwidth left, then please also send the webcam image. And this is nice, and this actually works if you watch out for some pitfalls. So imagine you want to be a bit more granular about this, and you say, okay, I have some video application, and the screen share actually needs to come through at the highest level, so only the highest layer, the best resolution, the highest bit rate of the screen share, that's very important for me, so that has the very highest priority. The rest of the screen share layers, maybe not so important, because if the connection is bad already, then I cannot do anything about it, but that's the most important priority. Then maybe the last layer of the webcam gets the second highest priority. So there's some use cases where you might think it would be great to do this on a simulcast layer level, and it doesn't work. It doesn't work for the spec says it should work for all. It should work, of course, for all browsers. But the problem is that for some reason, Chrome and Safari, in this, let's say you have 3 encodings specified, and they will only pick the first one. So they just do brackets 0 and check for if there's priority set. And if it's set, they will apply it. But if you specify the priority on any of the other layers, it will throw an error. So this is what you have to be aware of. And the cool thing is here, you can do it already in all browsers, but you have to be aware of to only set the priority on the first layer for all browsers apart from Firefox. And the last one is max bitrate, and we've recently discovered this. It's a bit of a, I mean, max bitrate is already self-explanatory. You basically tell it what's the maximum bitrate it can send in. And it's a bit of a spoiler with the image. Firefox is the one raining on the parade here. It's just ignoring that completely. You can make it, for audio, I have to say. You can make it work by SMP munging with max average bitrate, but that is also not a solution you can use for all browsers, because that doesn't work on Chrome. In Chrome, only the max bitrate setting works. Yeah. Enough of browsers for now. There's some issues here, as you see, and let's take a look at some of the stuff you have to deal with mobile and native clients. So there's one big advantage when looking at mobile and native clients in contrast to browsers, which is there's no different engines. Everything is running libWebRTC under the hood. And whoever has been just to the talk of Saul, there was an explanation of that already. It's basically Google's implementation of WebRTC with some additional client libraries for both Java and Objective-C, which are targeting Android and iOS, macOS mostly. But Google basically stopped maintaining the client SDKs. So for us, that means instead of inconsistencies between browsers, we are now dealing with OS-specific behavior, something that previously in the browser world, we've relied on browsers to abstract for us. And that, of course, surfaces some very different issues. One example of that is the recording indicator. So we all know if as soon as your mic is in use, at least on iOS, you get this little green dot, and that indicates your mic is on. Problem is, in libWebRTC, the mic indicator turns on as soon as a peer connection is created, which doesn't make too much sense, especially if you're only listening to something, or it's more of a one-to-many scenario where you're one of the listeners in a Clubhouse-like scenario. It feels weird for the user to just have that turned on. There are some workarounds for this. On iOS, for example, you have audio session categories, and one of them might be more suitable for playback, avoiding the mic indicator. One of them might be more suitable for a conference situation, turning that indicator on. But one annoying thing user experience-wise with that is each of these categories has a volume associated with them. So if you switch between them, it might be that you set the conference to very loud, you switch the category and it's completely silent, or the other way around, which is, of course, not nice. So in the end, we needed to patch it in a way that would only set the mic indicator active if that associated track is actually enabled, and we're hoping we nailed it this time, that this patch actually does what we wanted to do. And then there's hardware encoders and decoders. And of course, especially on mobile devices, you want it to be as fast as possible because there's not so many resources available. But also for hardware encoders and decoders, there's only a limited number available on each device. And this limit is device specific. And you don't know how many there are. And you cannot get that information unless you wait for it to fail. And then you know, okay, this is the limit. I cannot go any further. And we needed to patch something there in libWebRTC as well in order to free resources properly when the video is off screen. So if the video isn't actually being used, then you would like to free that space or that slot for an encoder or decoder, in this case decoder, and that needed a patch. So I want to come back to the original question of why can't we all just get along? And I put very, very hopeful just yet in brackets to look into a promising future. Just recapping a couple of things. So browser behavior of core WebRTC API still varies across different engines. Use WebRTC adapter, that's great. And then munge SDP until everyone is happy, which feels like the true WebRTC API by concatenating strings. Then there's media device handling, and it is inconsistent and far from fail-proof. One solution would be wrap get user media APIs with additional handlers and events. Emit as much stuff as you can to just tell people, okay, and then the most important part is pray. Pray that everything else works and believe in the hardware. Codec and simulcast limitations, as we just heard, are device and/or browser specific, and we aren't doing this yet, but this is our goal for the future. Establish a catalog of exact limitations of browser vendors, manufacturers, and operating systems, and basically have the server tell the client what it is capable of and what not. And this is basically the goal for the future. We would call it something like client configuration and override settings. I've heard from in your talk already that you have some server overrides already, and this is basically what we're aiming for with this as well. And another option of that is a backup codec, basically meaning this, I think this is something that Google Meet does as well. Imagine you're in a call where everyone is publishing VP9, and then someone joins who's not capable of decoding VP9. Two things can happen. Either you downgrade everyone who's on VP9 to VP8, so that one person can decode it as well. Or if everyone else is actually profiting from VP9, you can also tell them to send up an additional codec, which of course increases bandwidth a bit, but if we pair that with the Dynacast that we've seen before, so only actually publishing the layers that are currently subscribed to, that is a very valuable option as well. There's a third option.
Yeah, just disable the video for that guy.
So just leave them out of the conversation.
Yeah. You can still get the audio, not just.
Yes, it's if there's other workarounds, I'd probably say prefer.
Better than your other two options, in my opinion.
Okay. Just doesn't sound very inclusive.
You don't need to see people anyway.
And then there's OS behaviors change over time, and libWebRTC only addresses a narrow set of use cases, which makes sense. It's developed by Google. They have the use cases. So this is not really meant serious, but the solution is to maintain your own libWebRTC fork and patch bugs. With those patches, don't restrict use cases to meetings, but try to see the bigger picture of what WebRTC might be. And of course, that is lots of work, and we seriously do not recommend it. We currently do this, but it's not our goal for the future to keep doing this, because we would like to upstream changes or patches that we do. We started with that already, and just to close on the note, what I think helps us in getting along together, get involved with open source efforts to try to address common pitfalls or common issues that we all are facing, because we're all trying to solve the same problems, right? And WebRTC adapter is a great example of that. That is such an effort. And we currently have a fork of libWebRTC and the client libraries, which these are just taken from the GitHub repo as changes that we've patched in order to improve the situation there. And yeah, we will start efforts to try to merge it back upstream, but it's not clear how much of that will actually get approved. So for the time being, we do maintain that fork. And that's, and if you're looking for a stable build of WebRTC, because also Saul mentioned this in his talk before, Google doesn't provide any builds, we do. Get involved, check out the GitHub repo, and thanks for your time. And if there's any questions, I'm happy to answer them.
Thank you very much, Lukas. And here's a question.
So on the slides about the audio side, you mentioned audio NAC and Opus, right?
Yes.
Audio NAC is pretty much useless, right? I mean, by the time on the audio side, the NAC, you can't recreate
Debatable.
anything.
Yeah.
So,
yeah.
And Opus Red is, unfortunately, it just doubles the bandwidth unless you change the timing of the read packets, which not everybody has access to it. So what do you suggest to that?
So in the scenario of Opus Red, I would argue that as soon as you're sending video, of course it doubles the bandwidth of audio, but in comparison, it's a rather small fraction that improves the perceived quality a lot. So of course it's a matter of opinion whether it's worth it or not. But in our experience, I think we enable it by default, just not for stereo tracks, because then it would be like each channel and then read on top. But in our experience, it has improved perceived audio quality to such an extent that it is worth the additional bandwidth.
Yeah, and do you subscribe to the standard that you will duplicate every packet, or do you have some sort of a packet duplicate every 10 seconds or something?
I am the wrong person to answer that, but I'm pretty sure it's every single one, and it's only one. But I'm not completely aware of the. You can check it out. It's open source.
Thank you very much. Oh, Tim.
Yeah, I just wanted the great talk, by the way. Lots of good stuff there. Just wanted the like little
Nitpick.
No, not really. Actually, kind of warning. Actually, so the thing about the autoplay, right?
Yes.
There's an enormous pitfall for developers that Google have built for you, which is that if it has this heuristic which autoplay works after you've gone to a site more than 5 times within a week and it's got Google in the name, or like there's some random algorithm in there, right? Which is basically designed so that YouTube works, nothing else doesn't. But anyway, right, so the problem there is that you've built this app and you, at some point in the far distant past, you did do a get user media that was authenticated with a click.
Yeah.
And you played your audio, and then you changed the code 5 or 6 times, but it's still on the same site. And then you come back to it, and it works just fine, because autoplay is now authenticating you against your past session. You give it to the QA, and they say it doesn't work. And you think, well, I have no idea why it doesn't work. And the answer is, because you're not YouTube.
Yeah. It's called interactive media indexing or something like this. That's how they keep that catalog of how much you've interacted with the specific URL, and depending on that.
The fix is to test in
Incognito. Yes.
On a regular basis.
Yeah. Yeah. That's a good hint.
Thank you very much. We're running out of time, so we'll take those offline. But thank you very much, Lukas. And,
Thank you.
Well, thanks, everybody. And it's lunch break now. Then there's lightning talks in the panel room. And I'll see you back here at 3:40 for the last 2 presentations for the day. Thank you so much. Sorry.